Good morning to all. This session is in continuation of the previous topic. So, in the previous topic, we already given what are the conditions to be met with to solve or verify whether the given system is linear or not. Now, here in this session, we are going to prove it mathematically. Let us start. This topic, the concept is very much important. So, all students have to concentrate on this subject, on this concept. Now, let us start with. Now, so no need to repeat again, but for your understanding purpose, again I am repeating. To verify whether a system is linear or non-linear, three important points are going to meet with. First one is superposition, second one is homogeneity, third one is linearity principle. Now just directly now we are going to verify whether a system is linear or not. Now just look at a system is given like this. Equal to x of t or x of t. X. A signal is given. Or directly you can make it. You can make another one also. In most of the cases, they give that verify the signal x square is linear or not. In examination they give like this only. In any way they can give, but in whatever way they give, just now we have to follow the same procedure. Now just look at, this is the given input x square. In the first step, now we have to create two different signals, x square. This is x square of t or x square. The second one, x2 square. So two different signals we are creating. Next one, for these two signals, let us make two constants a1, a2. Both are not equal to 0. Now third step, then a1 x1 square and a2 x2 square. These two are different signals. Now fourth step, summation, sum. Then a1 x1 square plus a2 x2 square is a new signal which satisfies the condition as per the superposition rule. We got a new signal. Now in the next one, these two are homogeneous. Homogeneous means what? Or having the same degree. These two are 2 degree, homogeneous. So now two conditions are satisfied. Now the next condition is what? Linearity principle. That means what we have to show that? We have to show that a1 x1 of t plus a2 x2 of t, that is equal to a1 into L of x1 of t plus a2 times L of x2 of t. This condition we have to satisfy. Now just look at sixth. What is the seventh step? Now just look at, let y1 and y2 be two corresponding outputs. These two corresponding outputs such that y1 of t equal to transformation of x1 of t and y2 of t, that is equal to linear transformation of x2 of t. So this is one. Now directly, all these are steps required, verification step required, basic things. Now we are going for proof. Now just look at what we have to prove that. We have to prove that L of a1 x1 of t plus a2 x2 of t, that is equal to a1 L of x1 of t plus a2 L of x2 of t. These things we have to prove it. Let it be equation 1. Here this part is called LHS. Now this part is called RHS. Now we have to verify these two LHS, RHS individually. We have to verify. Now let us concentrate first. Take LHS. in the take LHS, linear transformation of A1. In A1, x1. x1 of t means what? X square. X square. Plus it is A2 of x1 square. This is A2 of x2 square. Output. Just we are taking the superposition signal as it is. So signal is x1 square, x2 square. So directly superposition signal we have taken. Now this is equal to linear transformation of A1 x1 square plus linear transformation of A2 x2 square. Now A1 is constant. You can make it outside of x1 square plus A2 linear transformation of x2 square. Now this is equal to A1 of what is L1 of x1 square? That is equal to y1 of t. y1 of t. This is A2 of y2 of t. This is second equation. That is what we got is, now what we got is LHS. That is the value of LHS. Just simply we substituted the superposition value and we divided. That means what? We made the single into two different signals. We got it, that summation. Now, next go for the RHS. Go for the RHS. What is RHS? What is the actual given signal? X square. Given signal is x square. Now just look at how I am writing. Just look at given signal is x square. Given signal is x square signal. What superposition signal we got? The superposition signal that is equal to A1 x1 of t plus B1 x2 of t. Now this is entire is a signal. Given signal is only x. What signal we got is superposition signal. Now substitute superposition signal in the given signal. In the given signal. That means what? What happens? Put superposition signal in given signal. Superposition signal in given signal. That is called x square. That is called x square. Then what happens? That becomes L of whatever the signal you put, output is square. That means A1 x1 of t plus, not this is A2, not B2, A2. This is A2. Now A1 x1 of t plus A2 x2 of t whole square. This is equal to, it becomes what? Whole square. So this becomes L of, expand, A1 square, A plus B whole square, x1 square plus 2 A1 A2 x1 x2 plus A2 square x2 square. No need to write t always, you can make it. Now just divide individually. That is A1 square x1 square plus L of 2 A1 A2 x1 x2 plus L of A2 square x2 square. Now here A1 A2 all are constants. Take constants outside. A1 L of x1 square plus 2 A1 A2 L of x1 x2 plus A2 square of L of x2 square. The output what you can make it? A1 L of x1 square is what? y1 of t or y1 of t. Now 2 A1 A2 of y1 of t into now A1 A2 into x1 of t x2 of t plus A2 square of y2 of t. This is the equation, third equation. Now just look at, no need to have any confusion. Here LHS is linear transformation of individual signals. RHS is substituting the superposition signal in the given signal. What is the superposition signal? As a whole. Superposition signal as a whole, we have to substitute in the given signal. Then output will become what? Square. In this way, it will become a plus b whole square. Expand the a plus b whole square. You will get 1, 2, 3 terms. Now just look at, this is LHS, this is RHS. What we have to prove? If LHS and LHS both are same, if LHS and LHS are both are same, then the system is linear. If LHS is not equal to RHS, the system is non-linear. Now just look at here. The system is what? In this system, what LHS you got? Only 2 terms you got. A1 Y1t plus A2 Y2t. You got only 2 terms, A2 Y2t. But in RHS expansion, what you got? 3 terms you got. Here it contains only 2 terms. Here it contains only 3 terms. 1, 2, 3 terms. Therefore, these two are not equal. If you verify the terms in the LHS and RHS, definitely 100% these two are not alike. Therefore, in this system, LHS is not equal to RHS. Therefore, the given system is non-linear system. So, in the non-linear system, LHS never equals RHS. So, here, which point we have to make it? We have to prove that linearity property. Now just look at sum of. So linear transformation of sum of signals is not equal to sum of individual signals. Transformation of sum of signals is not equal to sum of individual transformation of terms. Now just look at, so definitely as a student you can observe LHS contains only 2 terms, but RHS contains 1, 2, 3 terms. 2 terms can never be equal to 3 terms in another way logically. So here LHS is not equal to, therefore LHS not equal to RHS. Therefore the system is non-linear. Therefore the system is non-linear system. It is a non-linear system. Thank you.